Yeah, so let's talk about this architecture today. This is an ad serving platform which we are running on AWS, and this is an active active setup, and it is highly available, highly fault tolerant, and highly resilient to any disasters or any failures. Basically, this is an ad serving platform which we see in multiple websites like Amazon or Google. We There are things like Google Ads, right? So we have a user agent which can be an application running on mobile phone or a web page that user accesses. Then our service, its job is to just render advertisements based on the user's attributes like their locality, their preferences, their likings, what they have tried to browse in the past. So it is similar to how ads work in Amazon. Like you tend to get recommendations, and in Google you have like personalized advertisements based on your recent activity, right? So the user will access the application from the website or their mobile phone, and the service will be returning an advertisement based on the user, right? So it will look something like this. I mean, our user is here is Joe, and Joe is someone is a user in England. So Joe logs into this application, and immediately he sees this advertisement of an English player, right? And this is decided based on, this can be decided based on like a lot of factors, but for simplicity, right, like I have put it here as the location, right? So Joe is in Britain, and he's seeing the advertisement of an English cricketer. Similarly, like if I have a user called Kane, he's from New Zealand. He should, when he opens his application, he should see an advertisement that is relevant to him. Or if you have a user in India, he should see an advertisement that is relevant to him, right? So this is the application that this is a basic like ad serving application. So for simplicity, I'm using images here, so it can be anything. It can be short videos, animations, or anything, right? So this is the small prototype of the application that we have here. It is an ad serving platform. So we are going to design this in AWS, and we're going to see how it actually works. And so how would you go about designing this is the first question, right? So I would say that it is better to go bottoms up. Whenever you're designing something, you want to understand the requirements first, and then decide your storage, right? Then you would decide how your application will contact that storage, how your application will scale, based on the requirements. Like our requirements is that this application should be global, and it should be like globally scalable, fault tolerant, resilient, and all that, right? Finally, we will have the third layer. Like we have multiple layers in our architecture. We have like 3-tier architecture in AWS. We have a web layer, we have an application layer, we have a data layer. So we will have something on the web layer also to figure out how to expose our application to the world, right? So these are the things that we would think about when thinking about um, our application. Uh, so the first layer will be my storage. Sorry. So storage I will decide based on what I'm expecting my application to do. So for example, this is my application, like it's a prototype right now, but I can see that what I'm doing here is I'm rendering an advertisement, and this advertisement is it can be a video, it can be an image, an animation. So basically it's a blob file that I'm like rendering every time, and it can depend on uh, the ad campaign that my organization is running. So I would decide the advertisements based on that. I would create some graphics, like I would not create, but we the organization would create some ad campaign, some graphics, some videos to show to their users so that they can like click on them and use them. So this part of the storage is an object store. So if you see here, it like it's an image is a it's a contiguous blob of data, right? It's not text, it's not metadata, it's just a contiguous blob of data which doesn't change that much, right? And if it changes, it changes entirely. Like there you won't be changing an image, like you won't be changing a pixel, you change the entire image. So that's the point behind using an object store. So the first service that comes should pop into your mind when you think about advertisements and static blob of data in terms of images and videos is S3. So S3 would work as our object store. So this will be our object store for this project. So that is the first thing that we should think about when we think about um, producing ads on the internet, right? Second thing, in our application, what we are expecting is there is some metadata about the users that are stored at the backend. For example, I have this user Virat, and based on the metadata of Virat, I'm getting this advertisement, right? And if I change the user, I get a different website. So there is something stored at my backend, right, which is deciding what ad to show to Virat and what ad to show to Kane, and it can be anything that their personal preferences or likes or what the system has learned about them, based on their shopping, past shopping data or their location, right? Or I can have a ad campaign which can simply say that okay, people in this location should see this ad, people in that location should see the other ad. So it can work like that. So for metadata, to storing my application metadata, I would have something, it can be anything, like in AWS we have, and in general we have like two options, RDS or DynamoDB. So RDS is a SQL database and DynamoDB is a NoSQL database. So they both fit in here. Like you can store the metadata in RDS also, you can store it in DynamoDB also. It won't make much difference in terms of like storing the data, but uh, there are several architectural decisions that would influence this, right? So why did I choose DynamoDB, as you can see here? So the one advantage of DynamoDB is that you get global tables, so you can actually build uh, resilient or fault tolerant application globally. Like I can have one uh, deployment running in US, one deployment running in Mumbai, and I can run them anywhere with very low latency and uh, low latency between my databases, which I can write to. Right. In RDS, I have some limitations that I can have read replicas, but I cannot really have this multi-master sort of setup to store my data. So this gives me a nice, so a way to sync my data across global regions and to have it available globally. And I can write in any region, right? I can write in US region and it will be replicated to EU or Mumbai, and I can write in Mumbai or EU and it will be replicated to US. So I can access this application from anywhere, and I will get instantaneous data, and I can write to any database, right? So that is the idea behind this, that you can do other thing also with RDS, but uh, the the thing with RDS is that you can write only once, right? You will be able to write in only one region, and then you will have to replicate the data with read replicas in another region, which is good. Like if your application is only doing the read, then it's completely fine. But if your application is also supposed to write, then DynamoDB has some edge over uh, RDS here. And other than that, there are few other things like data consistency. Like if I want my data to always be consistent, if I want it to follow ACID principles, it should be I want my data to have transactions, right? And if those transactions don't go through, my data should not be committed, and I should have some way of resolution, conflict resolution between my databases. For example, DynamoDB here resolves conflict by whoever gets to write second, right? For example, I write something here, I write attributes about a user, and I write attributes about the same user here also. But the problem is that with DynamoDB is that if this application writes first and this application writes second, this one will win, right? The write happening later will win over the write which is happening before it. So it depends on application to application. So the main, I would say, the reason choosing relational database or NoSQL is how consistent you want your data to be, right? And how critical your data it is. Like obviously, if you're using a banking sort of a solution or something very critical dealing with credit cards and all, you would probably not want to do your transactions over DynamoDB, right? So it has its pros, it has its cons, and for this application, I think since we are just serving ads and we want this architecture to be global, this is a better trade-off, right? So I would decide in favor of DynamoDB with global tables, right? So my storage layer is sort of fixed here, right? So I've decided I'm going to use DynamoDB. I've still not decided on how I'm going to do all this, and I've decided how I'm going to store my objects, and it's going to be in S3. Second is my application layer, right? So how am I going to run my application? So that again, can we have like multiple compute uh, resources in AWS, or in general also we have EC2, which is we get an operating system, we get a Linux or some other virtual machine, or we have serverless, we have EKS, we have ECS. There are a few others also. So I have to decide based on them, like which ones do I use, and there are trade-offs to everyone. Um, so I would use EC2 if I'm doing something um, on the kernel that is being given to me on that OS. But in this application, I'm definitely not going to use the kernel, right? So I can make use of containers or just serverless. So this one goes out of uh, contention for me, and so does EKS, because I don't really go for Kubernetes until unless it's really required, right? I always prefer ECS because I feel it is easier than running Kubernetes cluster. I mean, it has its own uses, but right now I don't see we making any use of Kubernetes here, because all our uh, requirements are being fulfilled by ECS when containers are concerned. Like we can have auto scaling with ECS, we can have replicas, so we don't really need Kubernetes here, right, for this particular design, right? So eventually it basically comes down to whether you want to use serverless or whether you want to use ECS. And this application, I think, choosing serverless and choosing ECS becomes more about the nature of the traffic, right? If my traffic is very sporadic, right? If I'm getting traffic only on particular times of the day and it's very sporadic, and sometimes I get spikes, sometimes it is very low, then it doesn't make sense to run constant amount of compute, right? If my traffic pattern is like fluctuating so much, right? So if my traffic pattern is like that, I would probably use something like Lambda, right? Which is serverless, which has its pros, like it can scale like in, like in an insane way. It can scale in and out very quickly, but there are few problems also, like it is not very fast because you have things like cold start, so you need to have some like provision concurrency with it, and you need to have um, You need to make your serverless applications not have cold start. You have to keep some instances warm so that when the requests arrive, you can like uh, serve them real time. So that is something which uh, which is a drawback. So I always prefer that if the traffic is sporadic and I have event driven architecture or these sort of things, then I would prefer Lambda or serverless. But if my traffic is more or less the same, which is in case of an ad serving platform, because you have users logging in and out um, mostly on a regular basis, so you know, like you have some uh, level of fluctuation, but it is not very high or very low, right? And second thing is you are not wasting compute because you have a constant influx of requests coming in your way, right? And second thing which makes me favor ECS is the synchronous nature of this application. So the request, as soon as it arrives, it lands on our ECS, and our ECS doesn't have anything like cold start, so it can serve the request very quickly. And for an ad serving platform like this, you can expect millions of requests coming in and out, right? So ECS is the more suitable work workload, sorry, most suitable compute service that we can use here for this application. And ECS can run with auto scaling. You can have multiple replicas, as you can see. I have chosen like 0 to 3, but I'll come later to it. So for now, this we have defined two pillars of our architecture, which is storage, which is our application, and the third one is the web tier of it. This is the third tier, like how I'm going to expose my application, right? So here in this architecture, if you see above, you will notice that our user is making two requests, right? Why? It is not making one request. Um, for example, let's say my user is contacting my load balancer, my application, then my application is doing some compute, it is figuring out what user it is, what ad to show. Now I have two options, right? I can either pass my ad through my ECS, right? I can have the user contact my ECS and have the ad rendered over there. Then the ad will go through my load balancer entire network and it will reach me, right? That is one uh, option. The second option I have is that I return a URL, right? S3 URL for my advertisement, where my advertisement is hosted, and this makes my application fairly quick, right? It is only doing computes, right? I am not overloading my buffers. I am passing less data through ALB, so my responses become faster. I'm not rendering and I'm not serving very big video files or very big images through my ECS. I'm simply giving a link. Okay, this is the link, this is where the ad is, just go and fetch it. So that is one thing which we see here, right? And my ad is static, my ad is in S3, right? And I'm basically sending a link and the user will go through that link to get that advertisement. So I have divided my fetch operation into two operations. First operation is the compute part of it, like I will open my application, the application will figure out okay what ad to show this user, and this is happening here. And the second part is actual showing that once you know like what ad to show to the user, then the second part is happening. Then we are contacting the actual object store to get the ad. So my web tier will definitely have two components. So the first component will be the component where I'm doing the actual compute about what to show. The second is when I'm actually showing it. So let's talk about the first one, right? So ECS. So I am going to host my application in ECS. So ECS, I will be exposing my application over port, let's say 8000. So here what I can do is I can have a load balancer, which is an application load balancer here. I can terminate my TLS on ALB, I can attach a certificate. I can create a certificate in certificate manager. I can attach it to ALB. I can terminate my TLS here. So whenever a user comes, this serves as the third web tier for my application. The user will see the certificate, the TLS, and check will happen. Then it will move on to my application. The traffic will be routed to my application, right? So that is my from my application side. This is my first layer of web, which will be served by ALB, right? And at ALB, I can also make use of WAF, which is a web application firewall. So this can help me secure my application against malicious attacks like cross-site scripting or SQL injection attacks or DOS. For DOS, I can use Shield, and there are like multiple rules that I can attach via WAF. There are OWASP rules that I can use in WAF service. So AWS WAF provides a lot of these rules which are already defined by AWS, and you can apply to your ALB or other web-based services. So this makes my third tier from my application perspective, but now I want to think about multiple regions, right? Because I want this application to be global, and my load balancer cannot span regions, right? It is a regional resource like ECS, like DynamoDB, so it will be hosted in only one region, right? So but I want to host my application in multiple regions like US, EMEA, India, others. So what ALB can I use, right? So here I'm going to use another sort of load balancing, which is DNS load balancing, which is latency based. So I'll basically create one DNS record for my application, and this will be route 53. So I will create one record for my application, and I will point that record to all the ALBs that my application is having. So if I'm like, let's say if I'm hosting my application in 3 regions, that record will have 3 IP addresses that it will forward to. Not IP addresses really, but ALB actually exposes host name. It does not expose an IP address because IP addresses change in ALB. So I will probably have a CNAME record here for an alias, which will forward traffic to ALB which is closest to the user, right? So user will contact route 53. Route 53 will contact okay, this what is the latency for this user to reach this ALB, and based on that it will point the user to the nearest load balancer. We can also use geo based for this, like it can give the user the correct load balancer based on where the user is located and where the nearest ALB for them is located. But this one is, I think, mostly latency based. So route 53 will send a query to all load balancers. So whichever LB will come back faster, it will return the response. But if I want my application to be truly global, I think I would probably want to have geo IP based routing. So if my user is in New Zealand, and if my user is in New Zealand, and then this route 53 should route the traffic to load balancer in Australia or New Zealand region, correct? And if my user is in India, the route 53 should route the traffic to the load balancer in India, something like that, right? So I've got like one part of it covered. Okay, I'm going to use load balancer plus route 53 to do the load balancing for my application. Now I'm going to serve the data. The second part is I'm going to serve my data, which is in S3 object store. So here the problem which can arise if my requests per second are very low, like I have like couple of users, then it doesn't matter to fetch directly from an S3 bucket. I can open access to my S3 bucket object. My users can access S3 directly, right? They can fetch the add over S3 directly, but it becomes a problem when I'm scaling my application, right? Because at some point I will have millions of requests per second coming in. I'll have multiple users. Think about Google or Amazon. So they have like a lot of users. They need to serve a lot of advertisements, and you cannot access S3 um, again and again for the user. It can create a lot of latency, right? Your ad can take up a lot of time to load, and this is not desirable. So for that we have to use CloudFront, which is a CDN. So this will front my objects. This will front my ads. So the CDN, which is CloudFront, will serve as a front for my ads. So what it will do is it will basically cache all the advertisements. And CloudFront is a truly global service for AWS. So it is no matter about the origins, it will scale to all the AWS regions, and you will have an endpoint of CloudFront in all your AWS regions, and the users which is contacting CloudFront will be having something similar that we discussed earlier, right? So let's say my user is in New Zealand, and it contacts the CloudFront endpoint, which I will show soon. So CloudFront figures out that where this user is accessing it from. So if he is accessing it from Australia or New Zealand, the CloudFront will internally route the traffic to their CloudFront servers, which are hosted in Australia and New Zealand, right? Similarly, like if my users is in America, then CloudFront will route it to the nearest CloudFront services servers in America. So this is done basically to provide very low latency, so that wherever my users are, they can access my objects on a very low latency network very quickly. Second thing CloudFront does is it caches the objects. So the advertisements that we saw, for example, this image, it can be a very big image, or it can be a video, and it doesn't make sense to just fetch it time and time again from S3 over a very long network, which can add add a lot of latency over the path. So what CloudFront does is it downloads the objects and stores, it caches the objects inside itself. So now whenever my user is trying to access it something, so if my user is in America, it doesn't matter where my bucket is located, my object is already cached in the CloudFront servers in USA. So I get the object very quickly, right? So this is a very significant jump from accessing the objects directly from S3. I can access them from CloudFront, and I can apply WAF rules in CloudFront. Also, you can apply WAF on CloudFront or ALB or anywhere which is any endpoint which is exposed to the internet. You can apply this firewall. So I can have like different like rules for my CloudFront, uh, preventing DDoS, or having some sort of rate limiting to prevent exhausting my CloudFront budgets. So this is basically a walkthrough, like how you would think your way through this design. Like few things I want to talk about now is that we want to make it fault tolerant, right? So if let's say I'm hosting it in two regions, I'm hosting it in US and I'm hosting it in Mumbai. So if my US region goes down, I still want my application to run, right? Given it can be a little slow, like let's say my US region goes down, it can be a little slow for my users in that particular region to access my application. They'll have to go to some other region, but uh, it will be available. It will not go down just because one region is down. I mean, region going down is like the worst case scenario, but this is just a requirement for our application, right? So we have this, right? So DynamoDB, we have discussed that we are going to use global tables, so they can scale anywhere. They can scale to any region that you are deploying to. So they are replicated in that sense. ECS application, which is our app server, is, if you look at it, it is really it is not stateful. It is like stateless, so it can have a different service or a cluster running in a different region. So US will run its own cluster, and EU or Mumbai, they will run their own cluster, right? Similarly, like I'm coming to ALB, so each region will have their own ALB. But S3, I have chosen to use like a cross-replicated S3 buckets. So S3 doesn't have to be replicated into all regions. You might want to replicate it onto one more region, basically to protect against disaster, right? For some disaster recovery or being fault tolerant. So if one region goes down, you can still serve your content through the other region. So CloudFront will have both these regions as origins. So if region 1 is down, it will contact S3 of region 2, and if region 2 is down, it will contact S3 of region 1, right? So it will work something similar to that, and the replication in S3 will work like if you add an object into S3 1 bucket of S3 1, it will replicate it onto S3, and if you add an object here, it will replicate onwards to our first bucket. So these both of these buckets will be in sync with each other, and CloudFront will have both of them as origins. And so if you see this, we have made this layer of our architecture also fault tolerant. So CloudFront is global, Route 53 is sort of AWS global service. So now our architecture is truly fault tolerant, right? Any region going down is completely covered, we can rest assured, right? So there are a few other things that we want to think about when we think about this architecture is how we want to design our DynamoDB table, right? So one thing that we want to make very sure about is partition key and secondary key, that we should have our partition key on columns that should be queried, and we should make sure that uh, any column that we want to query, it should be keyed. It should either be partition key or a secondary key to avoid scans, because in DynamoDB, if you want to find a component which is not keyed, basically which is not indexed, then it basically scans the entire database, and it is very costly in DynamoDB because RDS, MySQL, they run engines. So if you don't have an index, they will go through, they will do a table scan, but the table scan in SQL databases is much more efficient. It uses binary tree also, and so it is faster than DynamoDB. But in DynamoDB, it is very costly, first of all, in NoSQL databases, plus it is very slow. So if you are querying on something which is not indexed, then it is going to be very slow. And partition key in particular, we want to, the column that we want to make partition key, we should make sure that it has high cardinality. Like it should not, that a username is a decent way to create a partition key on, because for different users the data will go into different partitions of DynamoDB, but a location is not probably a good idea, because 80% of your users can be from one location. So that will eventually mean that 80% of your requests will be going into this one DynamoDB partition, which will eventually make your DB query slower, right, and your bills higher. It leads to things like hot partition, and it is inefficient. So this is a thing that we want to make sure of when we are designing our DynamoDB tables. Second thing which we are seeing here is an interesting thing. So this private subnet and this VPC endpoint, they are related. So our application server and our database. So DynamoDB is a managed service by AWS, right? So our data is not public unless someone has authorization for our data. Unless we give permission to someone, they cannot access our database, right? And our data stays. We want, in some cases, we want our data to stay inside AWS, right? And we want our application server to be in a private subnet, because they don't have any reason to be in a public subnet for security point of view, because we have opened one subnet here which is public subnet to the internet. So this provides an additional level of security, right? So this subnet will have their own network ACL, so we can maybe create, maybe make them more narrow so that it is more secure. And so it is mostly about security posture, like you want to make the workloads running in this subnet to be private, like they should not be accessible to anyone on the internet. So this adds one more layer of security over your data, right? Because you're accessing your data over these compute resources, and these resources have access to it, you know. So I basically attached IAM roles onto this ECS clusters to access the DynamoDB table. So you want to secure them, right? So the problem which comes with private subnet is that uh, sometimes you want to access something over the internet, right? So if that is the case, then definitely you would use something like net gateway. So this is essentially for things like if you want to access some repository which is on the internet, and if, you know, there is no other way to access it, then net gateway is a good uh, way to open a one-way connection to the internet. So ECS will, so your net gateway will basically be created on the public subnet, and your private instances will contact net gateway to reach the internet outside, right? But it doesn't make sense when we don't have this requirement. And in most companies, in most cases, you don't want your traffic or your private traffic to leave the private subnet or leave the AWS network. So for that purpose, we have something called VPC endpoint. So in our architecture, we are using ECS, and ECS is going to pull images, right? Pull images from ECR. It is going to write container logs to AWS CloudWatch, and ECR images are stored in S3, so it will probably make connections to S3 as well. And we are definitely making connections to DynamoDB. So normally, if we don't use VPC endpoints, there there is no way for our ECS tasks to reach DynamoDB, right? I'm giving an example, because if my subnets are private, they cannot reach anywhere except themselves. So that is a problem, right? Or the public subnets. So that is a problem because you have no way of reaching DynamoDB. Like DynamoDB service is a global service, it will have its own DNS record, and when you query that DNS record, you will get a public IP, right? So ECS has no way to go through the internet unless you provide it net gateway, right? So this gives a better option to not use a net gateway. And another drawback of net gateway is that net gateways are costly. So the the cost is very high, and it is proportional to the amount of traffic that is flowing through net gateway. So net gateway becomes very costly, and especially for this use case where you're basically only accessing AWS service, then it makes no sense to use net gateway in it. VPC endpoints are much cheaper when you want to use something like that for it, because things like DynamoDB and S3 run on global endpoints, and they are free to use, and you will only pay a very marginal amount for ECR and CloudWatch. So for that reason, I've decided to create VPC endpoints to access these resources, so our ECS services can run freely in a private subnet, and they can have no contact whatsoever from the public subnets. Sorry, the internet. Then we come towards our public subnets. So our public subnets will be exposed to the internet, and they will have an internet gateway to do that. And basically, the rule that we are going to have is an ingress rule of port 8000. So this is the only port that will be allowed access onto our public subnet, right? And our public subnet will have public IP addresses which will be assigned to our load balancers and nothing else, right? And we will have an internet gateway, and our load balancers will have interfaces which will connect to this internet gateway to reach the internet outbound, and inbound we are only allowing port 8000. That's all. So we are very secure this way, right? And there is, I think I have covered mostly. So this is my architecture, so I can maybe just show you how it is. So this is my Dynamo DB table. So this is just a small demo table that I had created. So if I explore table items, you can see like I have created basically just a basic database which looks relational, but we can like add tags here based on the user attributes, and we can basically decide our advertisements based on that. And my tables are, they are global. This table is a global table which is replicated to other regions also. And so this is Mumbai region, which where it is replicated to, and my main region is in US East 1, which is North Virginia. So I have the same table there. So this is the global table on DynamoDB, and S3 is my second storage service that I'm using here. So this is my main bucket. This is the bucket which is in US East 1 region. Then I have a bucket which is replicating this bucket in AP South 1 Mumbai region, and I am storing my advertisements here. So these are my image files. These are basically advertisements based on a user. So in general, like if you're running an actual application, you'll have like very huge amount of data. So this is just a prototype. Then I have my ECS cluster here. So this ECS cluster is running one container. It is running a container, and I have it behind my load balancer, and I basically have my S3 behind my CloudFront. So this is actually how my application will look like. So let's say I'm accessing it over Steven. So this is the URL of my load balancer. Normally I would have it I would have a domain and I would use Route 53. Currently I'm not using Route 53, and it will be forwarding traffic to my load balancer. So this is basically my load balancer IP. I'm accessing my application right now. I'm here on my load balancer, and my load balancer has forwarded the traffic to my ECS cluster on port 8000, and my ECS cluster has taken the user name. I'm providing the username in the URL, this T1, and it has used this username to figure out which ad to show based on the metadata it has in DynamoDB, and it has figured out that ad, and it has figured out what ad to show, and it has uh, given the CloudFront URL back to us, right? And if you see this button, it has CloudFront URL which is given back to us. So if I talk about this request that I've just made, I have only completed this part. This part I have not completed yet. I have not contacted CloudFront yet. So now I will contact CloudFront with show ad, and now my ad is going to show, right? And if I inspect this element, if I copy the image address, if I paste it here, you see this is my um, object, S3 object, and this is the URL of my CloudFront distribution, right? So the flow should be clear now, right? I am accessing my application, it is returning a CloudFront URL. My user then accesses this CloudFront URL and gets the advertisement, right? So normally how it will work is you will open your application in your phone, and this will trigger uh, this workflow. So you will open your application, it will greet you, and then you will click on some button, your home page or something, then you will see an ad. So this is how the ads are being showed to you. Like the ads are stored in CloudFront S3, and the service is running on something like EC. So this service scales very well. It can uh, for example from few thousand requests per second to a million requests per second it can access, because ALB scales very well, Route 53 can route to ALB. ALB scales really well. It's an AWS service. Then ECS, we can change our auto scaling. Um, what what I can add, like there are few things that we can add here, is and one thing we can add definitely here is Redis or uh, DynamoDB accelerator, which is sort of a caching layer for our DB, because if we are scaling it in terms of requests per second and we are exceeding, we are like handling a millions of requests per second, then it doesn't make sense for my compute to query my database every time I run something like this. So a lot of users will be running this again and again, and I don't want to query my DB for the same thing again and again. So I will really benefit of having a layer of caching here. I can maybe use Elasticache or DX to use that. So this can be an improvement on this design. So I can add it here if I'm like serving a lot of data, but a moderate amount of IO DynamoDB can handle. Like it can handle a moderate amount of IO, and it can be handled. But if my IO is going to going to surpass uh, threshold, and if my queries are becoming a bit slow, then I would definitely benefit from using something like Redis or DX. And CloudFront is again a global service of AWS. S3 again is global of service of AWS. So they scale really very well. So there is absolutely no issue on scaling as far as these are concerned. And in terms of security, we have rate limiting and other injections and other attack security with WAF. So this is a very good architecture, synchronous architecture on AWS, which we can use as a reference. So this is just something which I wanted to share, and this is something which can be applied to multiple things. Like it is not limited to serving ads. You can tweak it or change it into serving multimedia files like uh, an MP3 player or over the internet or something like that. So the services are the same, but the configuration will always change based on the use case. And this is how I would go about it. So I just wanted to share this. So yeah, I mean, thank you for listening and goodbye.